Hello again. Welcome to Basics of Noise and its Measurement. This is the last lecture for this week on the topic of microphones, and what we will do essentially today is continue our discussion to understand how we go around making the right selecting the right type of microphone which meets our requirements. In the last class, what I had discussed was that there are 4 parameters which are crucially important in terms of selecting the microphone. The first parameter we had discussed was sensitivity. It should be as high as possible. The second parameter which we had discussed was the linearity of the microphone, which means that as the sound pressure level increases in pascals, the response of the microphone in terms of voltage it generates should proportionally increase. And if it's perfectly proportional, then it's a perfectly linear instrument, and that is something extremely desirable. The third parameter we had discussed, we had mentioned, was the frequency response of the system, and that has to be as flat and as horizontal as possible, and at least in the operating bandwidth of our interest. So those were the 3 characteristics which we had discussed, and today we will discuss a few more characteristics which are important, and that's what we are going to do. But before we do that, I wanted to show you some different types of microphones so that you get a feel for all the types, some of the important types of microphones. So this is one microphone, and you can see it from this side also, and its diameter is 1/8 of it's 1/4 of an inch, so it's about 6 millimeters in diameter. And this is, so I am just trying to show you different topologies of microphones what are available, and this may not be the only most comprehensive shapes, but I wanted to give you some idea. So this is, and here the microphone is separated, and then I have to connect this microphone with a preamplifier so that I can use it successfully. I am just looking at the sensitivity of this microphone, and it says that its sensitivity is 48.1 minus 48.1 decibels when the reference thing is 1 volts per Pascal. So this is one microphone. The other microphone I wanted to show you is looks something like this. So this is another microphone, and essentially it looks like a flat disc, very thin flat disc. Okay, and the signal is coming into this wire, and this side is the side which senses, and it's a very flat and thin, like a very thin coin. This is what this microphone looks like, and a lot of times you use these microphones, you stick them on the surface of an aircraft, and when the aircraft is flying you can stick it using some glue or something like that, and it will tell you what kind of noise it hears as the plane is flying. Why it is so thin? It is because you don't want the surface of the wing to have a lot of roughness and projections, so they have made a very thin microphone which fits this topology. So I will show you maybe 1 or 2 more different types of microphones so that you become aware of what is there in the field. Then you have this microphone which we had already seen. This is again a 1/4 inch or 6 millimeter in diameter microphone, and then this is a 1/2 inch microphone. This is a 1/2 inch microphone, and once again in this you have the diaphragm is there, which is the shiny thing, and it's protected by this covering, and there's this microphone is on the top side, and then this is the preamplifier. So that is there. And then the last microphone which I wanted to show you is actually designed to take measurements for high temperature applications. So what you have is some sort of a tube, and this tube cannot take a lot of high temperature like other regular microphones. But if you have noise in a high temperature zone, what you do is you attach this hollow, thin, slender stainless steel pipe to it, and you insert this pipe into the area where you want to sense the sound pressure level at high temperature, and so all of a sudden all the hot temperature will not reach this side, and if you are careful you can protect this microphone from high temperatures, and you can still manage to take sound measurements. And if the distance is even longer, what you can do is you have this polymeric pipe, and so if let's say the location of the sound source is fairly further away, so I can connect one end of this steel pipe to this polymeric tube, and the other end could be connected to this thing, and that way I can measure pressures in hot environments. The other thing I wanted to show you was that these microphones in general, they are attached to our data acquisition system by two types of cables. There are actually three types, but today we are going to show you only two types. One is this fairly standard cable, and this type of cable is known as BNC cable. Okay, so you can do a Google on it and you will see a lot about BNC cables. These are inexpensive and easily available. These are BNC cables, and you can actually get these connectors in the market, and you can make the cables yourselves. And then there's another category of cables, and it looks something like this. So in BNC cable you have one cable in the running on the axis of the cable, and then there is another conductor which surrounds that core, but here you have 6 on the periphery. So if you take front view of this thing, then it will look like the cable has the overall cable has one conductor on the inside and then 6 on the outside. Okay, so there are overall 7 connectors going through it. So this is another cable, and why I brought the issue of cable up was that while selecting microphones you have to be cognizant that what kind of cables you want, because you may have all the equipment and you may realize that you may don't have the right type of cable to connect your microphone to your acquisition system, so you may be having problems because of that. So now what we will do is we will look at some of the other important parameters while selecting microphone. So the first parameter, in addition to all the 3 parameters which we had discussed, was size. Now size is important because of 2 reasons. One is that if I have an area which is very constricted, then I need a small microphone where it can fit into. So that is one reason, that where the microphone should be able to fit in. But the second and equally important reason is, so size should be selected that it should fit into the application. But the second thing is that it should be consistent with minimum wavelength of interest, and I will elaborate this further. So, I had mentioned earlier that if my wavelength is fairly large to the size compared to the size of the microphone, then the sound pressure field does not get significantly altered because of the presence of this foreign object, which is the microphone. That is one consideration. The second consideration is that the directional characteristics of a microphone also depend significantly on the size of the microphone. So, omnidirectionality of mics goes down as size of mic goes up. Okay? Omnidirectionality of mics. If I have a larger mic, then it will be less omnidirectional, especially at higher frequencies. If I have a smaller mic, then it will be more omnidirectional even at high frequencies. And I will give a table. So, let us look at two microphones, 1 inch size and half inch size. Okay. So, I am looking at two microphones I will compare. One is having a size of, okay, it looks a little odd. So, size equals 1 inch and size equals half inch. So, I am looking at two microphones, and then we will see how the size influences their omnidirectionality. And let us say from 20 to 3000 hertz. So, if the frequency is of 20 to 3000 hertz, and if the microphone is indeed designed to be omnidirectional, then its omnidirectionality will be very good. For both 1 inch microphone and half an inch thick microphone. From 3 to 6000 hertz, okay. This is, so from 3 to 6000 hertz, this will be omnidirectionality will be okay. It may not be great, but it will be okay, and this will be good. From 6 to 10, so if sound wave has a frequency between 6 and 10 kilohertz, then this will be questionable. It will be questionable. It will not be, probably it will not be acceptable, and this may be okay. And if it is more than 10 kilohertz, then this will be actually bad, and this will be questionable. So, size of the microphone, the diameter of the microphone matters for two reasons. One, you may not be able to fit into the application of your interest, that is one reason, and the second reason is that it may significantly influence the directivity of the microphone. So, you have to be careful what kind of microphone you are using, what is its size, and what influence it has on the omnidirectionality of your microphone or directional characteristics of your microphone. So, that is the first thing. The second important parameter is power requirements. Okay, power requirements. So what does that mean? So some microphones need an external power supply. So there may be a particular type of microphone. If I have to run it, I have to connect it to an external, especially some of these microphones which use these LEMO connectors, they need an external power supply. They need an external power supply for running them. So I need one extra piece of hardware to run them. There are some microphones, so the data from microphone, so suppose I have a microphone, the data, so this is my cable, it goes to some box, and from here it goes to data acquisition system. This is one configuration, okay. So this is sometimes it's a LEMO cable. So this is case 1. In case 2, I may connect it directly to my data acquisition system using a BNC connector, using a BNC cable. So here I have a power unit and a conditioner. Here I have eliminated this thing. Here I have in configuration 2, this power unit has been eliminated, and the way microphone gets its power is that this cable, the BNC cable, it does two things. It provides power to the microphone and it gets signal from the microphone. So it does both. Okay. Here you need a separate power unit. So you need in configuration 1 you need a separate power cable. Now each of these configurations have their advantages and drawbacks, and I will not say this is better or that, but this is less complicated, configuration 2, and if you can get away with it, it also has a simpler cable. So if you can get away with it, then it's good for you. So this is another important consideration, that do you need an extra power unit or you can get away with it, and then that could also be a consideration for making the choice related to your BNC cable. The third parameter is there are some microphones and IEPE option. What is IEPE? It is an industry standard term, and it means integrated electronic. So some microphones could be IEPE mics. Similarly, we have some accelerometers, IEPE accelerometers, integrated electronic piezoelectric mics. Okay, this is an industry standard terminology. So it is not specific to a particular company or something. If you have this type of a microphone, so what does this mean? A lot of times you have this microphone, this is a mic, and the signal, as we have seen, which comes out of a mic, it is not in volts or millivolts, but sometimes it may be in microvolts also, it may be very small. So you have to be very careful that if you want to send the signal over a large distance, it may get corrupted due to noise. Okay, so before you send it over a large distance, you may want to condition it and make it more robust. So a lot of times you may have an integrated preamplifier. You cannot separate it. Okay, you can get the microphone and the preamplifier as a package. So you have an integrated preamplifier with the microphone, and this may be a piezoelectric. So with mic. So this type of configuration is what is known as an IEP type of microphone. Now there are several advantages of this type of thing. One is that so this thing, it may be doing all the conditioning, and it may also have the calibration information. So the signal which you will get will be directly interpreted as pascals. You may not have to convert it into volt using your minus 20, this sensitivity level and all that stuff. You may get directly pascals, So this preamplifier may already have a lot of calibration related information. It may make the signal cleaner. It may remove a lot of noise from it, and it may also amplify it a little bit before it is sent out for data acquisition purposes. So there are some microphones which are having this type of a feature, and those are known as IEPE systems. And now there is another term called ICP. So it is integrated circuit piezoelectric, so ICP microphone. Now IEPE is an industry standard term. It is not specific to a company. This ICP is something which is used by a particular company called PCB. It is used by PCB Electronics. So this is a brand specific terminology. Okay, it is a manufacturer specific terminology. It essentially more or less means same as IEP. Similarly, there are other companies, they have come up with their own terminologies. But the point what I am trying to make is that if you want to check whether your microphone is IEP or not, you may have to ask your manufacturer whether it is IEP or not. He may use this term ICP or some other term, but in general they will also be able to tell you whether it is same as IEP or not, because that gives you certain advantages, or it has calibration information, it has preamplifier built into it and things. So those are some of the advantages associated with it. So that is another thing. So so these are some of the important considerations I wanted to talk to you about. The other thing is that if you have a preamp which is integrated with this, then it again saves you less cable, the connections are not there, you cannot physically separate the two parts, which has an advantage, because whenever they joined the microphone and the preamplifier in their labs, there it would have been a clean environment, there wouldn't have been any moisture, so all that connectivity is more robust. So those systems may be more reliable. So this is another one. And the last parameter I wanted to bring to your attention is polarization. Okay. So we had, while we were discussing about different types of mics, we had said that there are some mics which are pre-polarized. For instance, these electric mics, the charge is already frozen into them. There are other mics which need an external power supply to polarize. So in those you have to have this external power supply, so you need some voltage to create the charge. So you may want to make a choice whether you need a polarized mic or a pre-polarized or a mic which requires external polarization. That again, in some sense, drives down to the question whether an external power supply is needed or not. Some of these pre-polarized microphones have somewhat of a lesser sensitivity, so that's the limitation, but then they don't need an external power supply. The ones which have polarization based on outside power supply, they are a little bit more sensitive. So again, each of these mics have their advantages and limitations, but at the end of the day, you should be aware of all these parameters, and then you should understand these parameters, see what your needs are, and then make a decision as to what kind of a microphone will meet your needs. So with this, we close today's lecture and also this week's of this entire week of lectures related to microphone. I hope you have benefited from all this discussion on microphones, and next week we will meet once again with another set of topics which are pertinent to the area of noise measurement. Thank you very much, and we will meet next time. Thank you.